Okay, hello everyone. I am continuing my work on my game, my jackbox-style game. So let me explain where we're at and what we're going to do today. So, excuse me. What I have here is this is my test harness. When I run my game in debug mode, I run all of the clients and the presenter in a single window. So normally each one of these clients would be like a phone or a tablet device, and all you would see is just this little area in the whole screen. And then and the way Jackbox works, that model of gaming is the presenter has a master screen that they share over some streaming service or something like that. But since it's hard to develop and have like all these devices everywhere, I have them all show up on the same screen, and they use a mock um, uh, network interface to simulate WebSockets. So anyway, so I can be playing here. So the object of this game is to use boggle-style letter spellings to connect your side to the other side. So let's imagine I'm purple. So I can move around the screen as a purple player. I can, so let's find a word, pies. You submit the word, and so it shows up here on the main screen, and then anybody else who scrolls over to that spot, they can see what's going on. And then, a yellow player can do something like, oh, rude. And then, oh, totally did not mean to spell that version of rude, but that works too. Okay, so here we go. All right. So anyway, the idea is to connect your team's color contiguously all the way to the end, and I can play the whole game from here in this um, mock-up. So today we need to figure out when we've won the game. So we're going to use an algorithm to do this. Let me bring up my whiteboard, and I'm going to describe the algorithm. So we're going to use a percolation algorithm similar to a floodfill. And so let me explain how that's going to work, and then we're going to code it. Okay. So you have a grid. This is a really horrible grid. I bet you there's a way to auto create grids on the whiteboard. Let's see. My son actually worked on this code. He could probably tell me if note grid. No, that's not it. Yeah, I should find out if there's an auto grid shape. Anyway, that would be nice. Okay, but anyway, I digress. So we have a grid, and we can imagine filling in squares on a grid like this. All right, and then we all understand. So let's just connect to the end. Okay, so when we speak about percolation, the question is like, does this percolate or not? And the question of percolation is, if I start here, is there a clean path for me to make it to the other end? Like if it right here, obviously yes, there is. But if like one of these squares were missing, it would be no. It does not percolate. This is similar to the floodfill algorithm where you click on some point, and then any contiguous point there will get filled with the color that you painted. So these are similar kinds of algorithms. So how do they work? Well, they're recursive in nature. I won't be using recursion for this. I'll be using a stack, so I can do it without using recursion. I'll explain why I do it that way. Okay, so anyway, how does it work? So we start, and let me erase this little thing that I made. Okay, so we have this grid, and there's an area of allowed places for the movement to happen. We start here, and we ask a question. So the algorithm goes like this. Is it valid? Is it a valid spot? In other words, is there an exit? Like if I started here, the answer would be no. You can't do this spot because there's no X in it. It's not a place that you've been. So if it's this spot, we say yes, it's a valid spot. So we mark it. So if it's yes, we mark it as visited. It's like we've been here before. Then we add to, then we check. I'll describe it recursively first, and so then recursively we would say, let's check. So we're going to do a recursive check. Okay, on the north. Actually, we'll just do like west, north, east, south. So recursive check, west, north, east, south. So what that means is that we go to the west and we repeat the algorithm. So we go to the west and we go, is this valid? Well, no, because this is the edge. So this is 0. So west is not valid. So we stop. So if no, return. Okay, so then we go to the north. Is it valid? No, because this is not a square that we're allowed to flood fill. There's not an X in there, so it's not valid. East, is it valid? Yes. So what do? We mark it. And then we begin this process of doing these other ones. So we check west, and is it valid? Yes. Okay, it's marked. So we need to ask a question here. We need to say, is it marked? No. We return. Oh, yeah, actually, yes. Sorry, we return. So if it's marked here, we return. So we go back and then we check the north. Is it north? Is it valid? Nope. We go here. Is it valid? Yes. So recursively, and we repeat the same thing. We check We'll come up here to the north. It'll be good. We'll mark it. We'll check here. Nope. 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 And then we'll do the south. Nope. And then when we're all done, and we move back up the recursion tree. So we've exhausted this guy. So we come back down here and we continue, and it's going to go over here and then go west. Nope. 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 And it'll come down here, and then here, and then back here, and then down, and eventually, and so by going through this, eventually we'll get to the end, following this very simple recursive algorithm. Now, I used to really like recursion. I mean, recursion's cool. It's certainly a nice concept, but what I don't like is how it uses up all of this stack space. Like function calls can be expensive, especially if you're passing a lot of stuff down on the stack. And so I tend to favor using internal stack variable and lambdas over just pure recursion. So you're going to see that today. So let's make this algorithm happen. Just hold on. Okay. Okay, so now I started it here. I'll just uncomment as we go. So, there is one more check here. And so we're going to be doing this flood fill. And the way that the flood fill will work in this game, let me make this bigger so we can see more clearly what's going to happen. So the flood fill, so basically every time we place a word, we want to see if that team has won. And the way that we do it is we're going to attempt a flood fill from any occupied square on the team side so let's make this more clear. So let's do the yellow team, and let's spell a word over here on the left. So, uh, um, ah, I'm so bad at this game. Had, terrible word. All this pressure to spell. Okay, so I'm going to start on the left side, checking for any yellow letters. And so here's one, and then I'll attempt a flood fill from here to see if we get all the way to the end. So in our flood fill algorithm, we're also going to be checking to see if we get to the end. If we can, it's a win. And you know what, since I'm testing this, I really should make this grid a lot smaller. So I'm just going to just temporarily go into the presenter model and change the default size of the grid. So the board size, I'm going to change it to like 8 wide by 20 or I don't know, 15 high, just so it's manageable. Save. Now let's clear it, come back here to a running game. Okay, so here's our game. So a nice smaller grid. So we're going to try to basically connect from here to here, and if we get to the edge, it'll be a win condition. Okay, so step one. So step one, figure out the edges. All right, so depending on which team we're checking for, we're either checking on the left or the right. So normally we're going to start on the left, and the winning X position is going to be the grid size -1. So this is 0. So if the grid is like 8, like this one, 0, 1, 2, 3, 4, 5, 6, 7. So it's always -1 is the last element. If the team is team B, we swap them. So the winning X is 0, and the starting X is this with -1. Okay. And the flood fill algorithm works the same in both directions, so we don't have to worry about it beyond the starting position and the winning position. Okay, so now instead of using recursion, we're going to keep a stack. So the stack is just it's just an array, and we're going to be using the push and pop functions on the array. Push and pop are pretty performant. They're order 1 on complexity, so they're pretty fast. And we're just going to use the stack as a way to keep track of work. And then, okay. All right, then what are we going to do? I wish I hadn't compiled that. Let me just shut up the compiler here. Console.log flood stack. Okay, be quiet, compiler. Is it compiled now? It doesn't like that. It never used it. Okay, flood stack. These are the days I wish why did it use strict? Because it makes this inconvenient. So start X, I know, plus win X plus flood, and then flood stack. I don't know. This is stupid. Okay, now it compiles. It does it. No, it doesn't. It is declared, but its value is never read. What are you talking about? I read it right here, buddy. Yeah, that's what I thought. Okay, now we're going. Okay. All right. So the first thing, what we're going to do is we're just going to go on the starting edge, and we're going to move down all the letters on the starting edge, and just attempt to use the algorithm on all these letters. So we're going to find all the starting positions. And so the flood stack, this represents all of the places where there is work remaining. So in recursion, the function stack handlers like kind of manage this for you. But if I'm going to do it this way, I just have to be a little bit more explicit. So this is work remaining. In fact, I could just call this call this work remaining, just to make it more clear. This is the remaining. These are the blocks that I need to check for flood fill conditions. So all I got to do is just say go down the edge, get the block at that spot, and then put it on the work remaining list. That's it. Okay, so this is our starting condition. Okay, now we're gonna just have a big loop, and we're gonna say while work remaining dot length is greater than 0. While we have work to do, we're gonna do some work. Okay, so we want to pop the block off the work remaining, so we're gonna say const current block is equal to work remaining dot pop. Okay, so that'll take the last item on the array, take it off, and make the array shorter. Okay, and so now we need to do what we said we're going to do on this little whiteboard thing. We need to say, is this a valid block? And so we say, meaning does it belong to this team? If if current block dot team is not equal to the team, not equal. That's one tiny thing I don't like about JavaScript is the extra equal. If it's not equal to the team, then we just continue. We're not interested in pursuing floodfill anymore because this is not even a block we can test. Fine. Now we want to add the north, south, east, west blocks. We want to say I'm just thinking there's an optimization we'll want to do here, but I'm not going to do it yet. So yeah, so we have the blocks X. So if current block dot location, no, dot position, no, we have the position somewhere here. ID is letter unselected. What? We don't. Coordinates, thank you. If current block coordinate X is greater than 0, then and then we can say work remaining dot push the grid this dot the grid dot get block it's looking ugly. So let's do const xy is equal to current block dot coordinates, and then we can make this look a little prettier. X is greater than 0. We're gonna push get block takes a vector. Oh, the current block dot coordinates. No. XY. X, and this is X minus 1. There we go. So we're going to take the block to the left, at the same row, as long as X is greater than 0. And then if X is less than this dot come on, this dot grid. Oh, wait, game size. I think it's game or board size. Board size dot x. If x is less than board size dot x minus 1. Because if x is board size x, it's on the edge. We has to be 1 over. Then we'll push x plus 1. Now we'll do the same kind of thing for y. So if y greater than 0, if y is less than board size y, what I could have done here is I could have just, never mind. Ignore what I'm saying. Ignore my mumbling and just watch what I'm doing. So that's y, and then this is x, and this is y. All right, and this is x. Okay. This is not the most efficient, but it'll work. So what this does is it immediately just flops onto the remaining work, the 4 ordinal directions. I have a feeling, it will never, okay, and we need to do an additional check here. Okay, but let's keep going. We'll come back to that. So the whiteboard, did I kill the whiteboard? Come back, whiteboard. Okay, so sorry, I have this cut off. Okay. All right, so the next thing is, all right, so we did this. Now we need to mark it. How are we going to mark it? So it's tempting to, let's mark it here because we have the current block. We'll mark it here. It's tempting to say current block dot visited is equal to true. However, we're going to be repeating this over and over again, and I don't want to just modify. I don't want to modify the block. This is like leaking the algorithm into the block itself. That's generally not a good practice. You want to separate the concerns. The only thing that cares about this visited stuff is this check for win. The block should not care about that. So we need to track whether we visited blocks, and so an easy way to do that is just to set up a map. So we say const visited new map, and we can do a number here and a Boolean. It's probably a hash set kind of thing, and I wonder if there's a hash set. I've looked for this multiple times, but I can't remember what I discovered. So is there a hash set in JavaScript? What is the equivalent to C# hash set in JavaScript? That's what I want. It's a set. Okay, that was easy. So visited is a new set of number. I know you're trying to be helpful. That was not helpful. Okay. So if you're in this set, you're visited. So we say visited dot set, visited dot add. Okay, now we need to add a number here. There's a couple of different numbers we could add. We could just add its a unique number based on its coordinate. That would work. I happen to know that the block itself has an ID that is unique for every block, and so that will work too. So this marks it as visited. So we need to do one more thing here. Our whiteboard algorithm here says we need to check if it's marked. And so before we mark it, we should check here, because if it is marked, we don't want to do any more work. So if it's not equal to the team or visited.has current block.id, then we're going to continue. And let's go ahead and just put that in curlies. It's a little clearer. This is a form of, I don't see too many people do this, but I feel like it makes these logic statements easier to read. This, I try to put, if you have a lot of chain together logic statements, I prefer to put like the or and the and pieces in front, because it's kind of hard to spot. In a complex logic statement, it's hard to spot them at the end. So I move them here to the front. I feel like it makes it easier to read the logic statement. Okay, of course this is like frickin' ugly. I don't think I'll just put it on one line. I don't think it's too bad. Okay, and then we'll just continue. There, that's nice. I like one line if I can get away with it. This seems okay. Okay, if we visited, or it's not the team, it's not valid, move on. Otherwise, we've visited it. Okay, and then we're going to add more work. And then we'll just keep popping work off until we're done. Fantastic. Now, one more thing. It's one more thing. And that is this. We need to know if we won. So if we've visited it, we can say if x is equal to winx, then we do whatever our win condition is. So handle, like, what do I want to call this? Somebody won. No, I'll just do handle game win. So we just handle game win for this team. I don't necessarily want to do it inside this function here, but, and then we need to return. Boom. And then we'll make a function here called handle game win team string. And I'm not going to do anything right now other than a console.log just to make sure that this is working. And I'll just say here console.log team won. Hooray. Okay. This dot handle game win. There we go. Okay, so now we need the only remaining thing to do here. So we have our, so this is it. This is the whole game winning check algorithm. Not too bad. Not too bad. Okay, now okay, we need a call check for win. So this has to happen whenever we correctly spell a word. So in placing a successful word, we're going to call this dot check for win. And we want to do the team. So we say the player dot team name. There we go. That's it. That was pretty simple. Let's see if it worked. Probably not. It never works on the first try. If it does, I will be so amazed, but I'm sure something's broken. Is it not compiling? It says it's compiling. but let's fix this little annoying thing on 375. 3 equals, of course. Save, refresh. Okay. All right, so let's make this smaller. And so that you can see what's going on. It's probably small for you guys, so I'll make this smaller here. Okay, so we're playing the game. I'll make this. We're just basically looking for the console to log that we won. So, all right. Now the boring part, you gotta watch me play the game. That's why I made the grid smaller, so it wouldn't take so long. Okay, so when we spell a word, well, you know what we should do is we should put here, we'll say console.log checking for win, because I just want to see if I'm making it in here, and I want to see a number just to see if everything is okay, and that is work remaining length. So we should, if I spell a word here in the middle, we should get that message, but there's no work. So let's just do a word. Fat. So bad at this game. Fat. Yeah, see, that's actually a little bug that I couldn't click and it was moving. That's I might need to tune that later. Submit. Oh, okay. This happens sometimes. Whenever I recompile, some of the state gets duplicated. This is going to bother me, so I'm going to clear all the memory and just start a fresh game so that goes away. Okay, so let's try again. Oh, there's fan. Thank you for giving me an easy word. Submit. All right, so it did check for win, but there was 0, no other work to do. Fantastic. So if we do, oh, look, we got fan again. I am such a one word kind of guy. 2, this is what we expected. All right, so let's connect. First, let's connect it with purple. Just make sure like irk is here. That's a great word. Okay, and it did check for a win and it found 1 for team 1, so that's fantastic. For team B, found that one here. Okay, so let's keep going with the yellow. Goo. And I gotta connect it. LAPS and LAP. Okay, so it's still checking for wins on each one, I think. All right, so that's not work. It's not there, and I'm just going to do another one here. Hops. Yeah, it's getting more. Yeah, that's good. Okay, let's make it win. So it's not winning because this C or this U is not done. So let's give, let's do Q. That should work. Team A1 totally worked on the first try. I don't believe it. All right, so let's do purple now. Since we're not actually stopping the game, we can just keep playing. So all right. So all right, this is where you can see an aspect of this game. You can take over spots if you can do words with more letters. So I think ROWE is a word, right? So that should let us take over that O. Oh, it's not a word. I guess I feel so embarrassed. Part. That's got only 4 parts. PARTS. Oh, let's do that. That you can take over the words if you can do longer take over letters if you can do longer words. That's part of the dynamic of this game. Let's do slays, S-L-A-Y-S, S-L-A-Y, let's do E-D, E-D, slayed. Okay, so we're getting further. And we need, this R is giving us a problem. Can we do R-A-I-N-Y, rainy? Yep, we're getting closer. And it keeps checking for us. All right, we just got to connect these two. So D-O-L-L. Boom, team B1. Okay, so it's working both directions for both teams. That is fantastic. So we can check off this work item here in our to-do. We got the win condition. Boom. So let's check that in. Let's make sure that the code doesn't look too weird. I always look for turds to see if, because I always leave stupid things behind. Like, yeah, this is a turd. Leaving this the wrong width and height. Okay, check for win. I don't want to have this console logging in here. That all works. That's good. And then down here, we did the play successful word. Okay, that's okay. That's so clean. That was better than I thought it would be. So, Lexible added algorithm to check for winning condition. Okay, now the next thing we want to do is did I not save that? No. Huh. Okay. I thought I had made something here. Okay. For the win, we actually want to end the game. Or bring up a win game screen. So what do we want to, when the game is over, what do we want to do here? We want to, there are several things that need to happen. We need to change presenter state to game over, and game over, we need to show winner screen on the presenter with let's see, we should offer to play again, and we need to send game over to clients. We need a game over screen on the client. And I think that's all we need to do. Okay, so let's do these one at a time. Okay, so let's go to the presenter. So, all right. So let's do a little explaining here. So the way that I organize my code is I follow roughly what's called an MVVM model, model view model. I want to separate out this idea of thinking about the game and how it works versus showing the user what's going on. So you have UI that interacts with the user, but the UI is dumb. It does not really know anything about the game itself. It just knows how to skin what the state that the game says it's in. The game doesn't know anything about the UI. It doesn't know about color or dimensions or anything like that. It just knows abstractly about, like in this particular game, it's thinking about the blocks, or it's thinking about the letters. They're arranged in a grid, and they can spell words or not. And there are a certain number of players. They have names, things like that. So if we want to change the game state, that would definitely not be in the UI code, because the UI doesn't know anything. It doesn't even understand that there's a game state other than it needs to render based on the state, but it doesn't know that when the game state should change, for instance. It's not that smart. So if I'm going to change the game state, I know automatically that that needs to happen inside one of the models, not inside one of the views, if that makes sense. So I have this presenter, this presenter component is responsible for drawing the screen, but this presenter model is for thinking about the game. So let's go here. Let's welcome. Okay. So here, we need to change the game's state. So handling the game win. We're going to say this dot state, game state. I need to do something here. This is backed by this guy. It really should be private. This should be private. Like my child classes should not know that there is this secret variable, because I don't want to accidentally change it. That should not be allowed. All right, this dot game state is going to be equal to flexible game state dot. We have this end of round message, so let's do end of round. We already have that. In fact, I might already show an end of round screen. And we need to set the winning team. This dot winning team is equal to team. And that's all. That's all you need to do in handling the game win. Because the model just cares about switching states. If you want to do something really fancy for the game win, we're going to have to do it in the views. We don't have a winning team variable, so we just need to add it. And we'll just make it a observable like the other ones. Oh, presenter model. Here we go. Boop, boop, boop. Actually, we don't have very many observables here. Okay, so we'll just put it up here. Observable winning team. I'm going to want to use an action to change this. Yeah, I think I'll do it like. Sometimes I get lazy and I don't want to do it the way I'm going to do it here, but this is really a good pattern to follow, I think. Winning team is equal to nothing. Then we have a get winning team, and it's return this dot winning team. I really should make a macro to do all of this. I used to do this in C#. I'd make macros for this kind of code. Set winning team value. See, I'm being lazy. Look how lazy I'm being. Value. And then you do this inside an action because it's mobx, and This is the way you do it. Action this dot winning team is equal to value. There we go. I just hate typing this boilerplate crap, and that's why I should really make a function for doing it, a macro for doing it, because the old MobX used to be able to just do this and it worked, but now you're supposed to do everything inside an action now, and so this is the cleanest way, I think, because down the road you want this because you don't want people ever manipulating this, and you don't want to force all the potential changers of this that they have to do an action. So I use getters and setters to force the issue here, and these end up being good places to hook code later. So I just hate typing in all that stuff. Now I have a winning team. Now I've set the thing, and oh, you know what? I'm going to need a trivial way to test this. So I'll add a trivial test in here. Okay, it's got an error somewhere in this code down here, and it says you can't change that. Yes. Ah, see, look at this. This is exactly why I needed to make that private, because I was accidentally referencing the game state as an underscore, the private representation of game state. Bad. That was bad. Don't do that. Okay, so let's clear everything. Start fresh, and oops. Okay. Sure. Okay, so this is a pain to have to go all the way through here. So I'm just going to make a button up here in this developer buttons to trigger the win condition, like right off the bat. So let's do that. I'll make it just a little win A and win B buttons. So that is in the view. And let's go to, is it dev only, dev UI. So I made this little class here called the dev UI, and it draws those buttons. Let's go to the definition. There's another class inside the dev UI. There's this other class called the dev only, and what I really should do is I should like have a thing for adding extra UI here. So that's easy actually. I'm just going to do this.props.children, and that will automatically add the stuff here. So this will allow me to put some things in the dev UI. So back to the presenter model. So where did oh no, not the presenter model. The presenter, there's this dev UI thing. And so what I'm going to do is I'm going to say dev UI, and I'm just going to add a couple buttons. Bing. And we'll have a button that says win A, and another button that says win B. Let's just make sure oops. What just happened? Win B. Save. There it is. So there's win A, win B. Excellent. Alright, so I can just choose who's going to win. That's cool. And this will not show up in the production. It's just for development. So cool. Okay, so when AB on click, we just say that we call function that does app model dot handle game win A, team A. And on B, we're gonna handle the game win on B. Don't forget curly. Boom, win A. Okay. The state didn't change. All right, let's see what happened. I expected something to happen there. So let's see if that even worked. Handle. Oop. I could just go from the presenter. Go to definition. Are you getting called? Let's do, let's set the winning team here, and let's do this. The reason I'm setting the winning team here is this will trigger a game save. And so I want it to save this if the game gets saved. And let's just do a console.log win. And what's our game state? Is our game state what we think it is? Save. So if I do win A, it says it's end of round. Oh, see, that kind of worked. So clear everything. Sometimes the compiling is weird, and we don't get the condition we want. Yes. Yeah, that's what we want. We want the end of the round. I guess we'll just start the next round, and it starts a new game. End of round 3. Game was over. Oh, that's interesting. I guess there's 3 rounds. We'll fix that later. Okay, so the end of round should show which team won. I'm kind of thinking that I want to be able to see all of the stuff that's behind. So I think if it's the end of round, I'm still going to show that presenter screen the way it is, but we're going to have some animations on top of it to indicate that the team has won. So that's what I want to do. So back to the presenter viewer. Let's find end of round. Yeah, so this end of round, I really wanted to show the same page as this one, as the playing. But in the playing page, if it's end of round, we're going to do something a little bit different. So go to the definition of the player page. So in the render here, we're going to do this, but we're going to have an overlay. And we're going to say appModel.gameState is equal to lexible state. No, listState. Lexible state game state dot end of round. So if it's end of round, we're going to show something. Otherwise, we're not going to show anything. And the thing that we want to show is, I'm not going to make a whole class for this. I'm just going to say render end of round overlay. Do-do, do-do, do-do. See, I should make that a macro too. I'm just too lazy to learn how to do all the macros. Too lazy. Okay. And this needs to return a div end of round for now. And this will be wrong. Render end of round overlay. Boom. Okay, and it's probably, so if I do a win, yeah, it's not showing up. So we'll have to fix that. Okay, so we need to make some CSS here to render this properly. So we want the dot game presenter. Let's do an overlay, just in general, because I feel like we might want to use this in more of the places than one. So we will do a class name equals styles dot overlay. Hooray. And put it down here. Is it? I'm pretty sure it's rendering this. And let's change the overlay. So the overlay, this position needs to be come on, don't do that to me. Absolute. And I want the background to be red, just so I can see where it is. There you are. Hello, you. So you're positioned down there below the other stuff. I'll make this just slightly smaller. Hopefully it doesn't kill the viewing. So when we render this guy, go to def, and we come down here. So we render this div. So yeah, we want it. So if I say top 0, yeah, that's exactly what I was hoping. Okay. I want it to center, so I'm not quite sure how to do that in CSS. Let's query it. CSS position absolute centered. Absolute centering in CSS. That's what I want. If you want to center something horizontally in CSS, you can just do it by text aligning. Yes. Position absolute. Oh, really? Does that work? That would be just so easy if that just works. Well, okay, that was just super dang easy. Super dang easy. All right, so let's make this transparent white background. So pound FF 80. And maybe a little less transparent. 80. Maybe even less beady. Okay. End of round, and let's give it some padding. 20 pixels worth of padding, and it still needs to be darker, more opaque. Let's do D. Okay, okay, we'll do it. And then doesn't need a margin. Fine. Okay, that's good enough for now. I'm not a great designer. I'm gonna have some friends help me like skin this better later. We're thinking about the game. Okay. Move you over. All right. So now we're doing end of round and this thing here. So we're saying team. Yeah, team. App model. Oh, this stuff props. Okay, fine, we'll do it this way. app model dot winning team is the winner. Yeah. Oh. Okay, that 50% didn't work like I thought it would. We still have to fix. Is there a better one? So you must pull it back. Really? Okay, still easy, just obscure. And I think that we just need to have the style here, font size is like 200%. Make it big. There we go. That's nice. Team A is the winner. If I do win Team B is the winner. Oh, and we're not really starting the next round, so that's fine. Okay. So I guess we just need a button here that's like play again. So let's put this inside a div. And we'll put a button here. Play again. And is so humongous. I don't want it to be that big. But let's put some styling here. Equals. Let's do a class. Class name equals styles dot end of round text, and we'll do that here. Do game presenter dot end of round text. Yeah, I know my capitalization is not consistent. Sorry. And we want the text align center, and we want a margin of, say, like 50 pixels. Like that. There we go. And now we want the overlay to be like align items center. And we want to justify content center. Display flex. Dang it, bastard. Now I gotta do this other thing. Column. Do I do this somewhere else? No. Alright. There's flex direction column. No. Row. No. It's up here. It's up here. Flex direction. Nope. Column. Please work. Yes. Okay. There we go. And that button, I think that this button needs a little more margarine in it. Style. This is where I don't feel like it's worth styling this button with CSS. I get lazy. Margin is 20 pixels, I guess. There we go. All right, play again, and then the font size. Font size is equal to 100%. I think that'll make it smaller. Yeah, but let's do 80%. There we go. That looks nice. Team A is the winner. Play again. All right, and so when we click play again, we had another window that was the end of round page, and we just want to do this. Start next round. And if we go to start next round, this is on the Lexible Presenter model, and we want the current round plus total rounds. Go to definition. Let's just do a bunch of rounds. All right, so back to the presenter. We want to call start next round. So on that button that we made up here, where we've been editing code, we want to here, there's the style, and we'll just do an on click equals function where, oh, by the way, you're not supposed to do this. This is considered bad form in React. You're supposed to do this, and there's a reason. Const start next round click is equal to some function that does the same thing. Here's the deal. The React, the code that decides whether to re-render React, if you define a function here, it will always try to re-render this button no matter what. But if you define a function like this, it will realize that nothing has changed and it won't try to re-render the button. That's all. I'm trying to get myself in the habit of not just putting lambdas in there because it's so easy. Okay, so if we play again. Oh, okay, that's because I got to clear all the memory. Start fresh again. Clear start. Win A. Team A is the winner. Play again. Boom. Team B is the winner. Play again. Boom. All right. But look at that. It's not re-rendering a new game and sending the stuff. So let's track that as something that's next. I don't want to get there yet. So generate a new game when play again is clicked. All right, so we changed this. We are showing a winner screen, and we've offered to play again. All right. Let's check in what we have. Back to the presenter really quick. We don't need that. So on the presenter, where it's saying play again, up here, I'm just going to do play again. A little more of an imperative, like play again. Yes, I'm yelling at you. Okay, great. All right, now looking for turds. That's okay. That was a tiny fix. That was a cool fix. Render underground overlay. Yep, that's what we want. And we changed that, and we added these buttons. Love it. Here we doing some formatting and added that action. The winning team. We fix that and handle the game win. Okay, good. So Lexible added game winning UI. All right, so now the next part of this is now we need to tell the clients that the game was over and which team won. Okay, so this will be a little bit trickier, but we can do this. So we want to do this in the presenter model. So in the handle, the game win. What is this? Finish playing round. Yeah, so it's going to look like this. Where is that even called? Oh, yeah, this is... Yeah, this is kind of a bit of logic left over from some games have a time limit. This one doesn't have a time limit, so this code will never get called. So I'm just going to comment this out because we never do this. So I'll just say this is the kind of code we need if there ever is a timed stage. But we don't have a timed stage, and so this finish playing round is never going to get called. So I'm going to copy this and delete this code. We don't need it. And now we can do the handle the win. Handle game win. There we go. And so we don't need this turd anymore. We don't need that. All right, so send to everyone an end of round message that has a round number. And we are going to add the winning team is the team. Okay, so let's go to the end of round message. So this is the message we send to the other. This is the message we send to clients when there's an end. The round is over. So the clients probably already handle this. But I've been changing the structure of the messages to be more TypeScript friendly. So let's do that here. So I need a something like this, a data class that inherits from the message base. So this end of round message is going to have end of round message data, and then we will inherit from that one. The payload will be of that type. And now we don't need this because it's up here. Interesting, that was already there. And then, so now we can add the other v, which is the winning team, which is a string. Excellent. Okay, so that should have changed that. Back to the presenter model. So we're going to send the end of round message, the winning team. All right, so now when we click, I wonder if this will even work. Yeah, the round is over. So yeah, the screen's already there. So now we just need to say which team won. So let's search for that text. Actually, no, we'll just look on the client. So on the client model, so round is over. Why are we not finding that? Oh, because I'm in the model, stupid. Flexible client. Round is over. There we go. So here, if it's the end of the round, we're just saying the round is over. Round is over. Team, some team, is the winner. So how do we know the team? It's going to be on the app model dot winning team. So we need to add that. So let's go to the client model and search for end of round there. Client model, end of round message. So this is where we're going to go there, go to diff. And so since we know there's going to be a team here, let's copy the one we put on the presenter model so that I don't have to type in all that ridiculous code again. There you are. Flexible client, model, paste, excellent. And then the end of round message, go to definition. Okay, here we say the game state is end of round, and this dot winning team is equal to message dot winning team. Say the checkpoint back. Great. So now team, okay, that's not working because we just need to do it again. Team B is the winner. Okay. Let's see if we did everything. Did we do everything? Okay, so now we sent the message to the client. We did the game over screen on the client, and if we start to play again, we get to play. Okay, and it clears the client models, and if we do A, it'll do that. So the game cycle is working nice. Excellent. Okay. So one more thing to make this work, and that is we need to totally reset the grid. So in this, that was in the start next round in the presenter model. Start next round. We do this, do this, do this, do this. Okay, I think we want, there is a function for creating a new game. Prepare fresh game. Yep. We want to just prepare fresh game, set the game state. No, it just changes the grid. Yep, that's fine. So let's do this. Prepare fresh game. See if that works. So if we play again, choof, and it's the same, yes. And if we win, play again, poof, beauty, beauty. Okay, we did it. We have a winning condition. We can keep playing more games. That was excellent progress. Very happy. Let's look for turds. That looks all right. That looks all right. End of round message change. Yep, that looks good. So flexible. Let's go ahead and change it on the to-do as well. We did this, so we did all of that. Yes. Didn't have time for it, but next time we're going to be adding hints to the client so that they can see cool. For people who aren't so good at Boggle, we can give them hints as to what words are available to spell. We'll do that next time. Yes. Okay. Yep. I'm happy with this progress today. Flexible. Okay. Added winning UI to client. Done. And then I'll go ahead and deploy it. All right, thanks everybody for checking out the coding today. Hope you have a nice day. See you around on the internets.